Hi everybody, sorry that I'm out sick again. I wanted to make a video so that we don't get too far behind. So these are your 4.6 day 2 notes, and I want to walk you through them. So the only thing different about these problems today is you might notice that we have the inequality symbols again. So we're just going to kind of have to add a couple more steps to it, but otherwise it's still the same steps that you've been doing. So just like the other problems with the inequality symbols that we've had, the first thing I want you to do is make it an equal to problem. So I'm writing everything the same, but I'm going to use an equal sign instead of the inequality. So now these are the absolute value problems. So try to remember the two steps that we have for our absolute value problems. The first step is always make sure the absolute value is alone. So in this problem right now, our absolute value is alone. There's nothing in front of it and there's nothing behind it on that side of the equation. So now that we know it's alone, we need to break it into two equations. So I want you to underline what's inside, which is x minus 3, and we're going to break it into our two equations. So we have x minus 3 equals positive 4, and then we have x minus 3 equals negative 4. So now you need to solve these two equations. So we're going to add 3 to both sides, and x equals 7. Add 3 to both sides, x equals negative 1. So now, just like our inequality problems, we're going to put those on the number line. Now look at negative 1. Our critical number negative 1 is going to be a closed circle along with our critical number 7. Now we do need to test 0 because we need to figure out which way to shade. So 0 is in the middle right now. So we're going to test 0, which means we're placing 0 back into the original problem. So we're going to have absolute value 0 minus 3, and we have to figure out if that's less than or equal to 4. Okay, so 0 minus 3 is negative 3. That is still in the absolute value. The absolute value of negative 3 is 3. So is 3 greater than or equal to 4? That is false. So we have to shade far away from 0. But because this is an inequality problem, we're going to shade out in both directions. So I didn't shade in because that's where 0 is. So in order to shade far away from 0, I'm going to shade out. So the options for these problems is we're either shading in or out, just like our other inequality problems that we've had. Let's try number 2. So the first thing we always do is we change it to an equals problem because we see that inequality symbol. Now we're dealing with an absolute value problem. So ask yourself, is the absolute value alone? The answer is yes. So now we break it into our two equations. So underline what's inside, break it into the two equations. So we have x plus 2 equals positive 5, x plus 2 equals negative 5. Now we need to solve for x in both of these equations. So minus 2, x equals 3, minus 2, x equals negative 7. So there are our two critical numbers, so they need to go on the number line. Now we need to test 0. Let's see if I can get some room up here. So testing 0 means we're putting 0 in for x into the original problem. So we have 0 plus 2 in the absolute value, and we have to figure out if that's less than 5. So 0 plus 2 is 2. That's still in the absolute value. Absolute value of 2 is 2. So is 2 less than 5? That is true, which means we have to shade toward 0. 0 happens to be in the middle because it's in between negative 7 and 3. So look back up to your original equality. These are going to be open circles, and we are shading in the middle because we're shading toward 0, which is in the middle. Okay, now let's go back to those compound inequalities. Remember, if we're shading out, it's an OR problem. So for number 1, we're going to have x is less than or equal to -1, or x is greater than or equal to 7. For number 2, this is an AND problem because we're shading in the middle. So x goes in the middle, -7 and 3 on both sides, always less than symbols. You just have to figure out if the equal to bar goes underneath. And since they're open circles, no equal to bar. Now, before I go on to 3 and 4, I do want to remind you how to get absolute value in the calculator in case you want to use that to test 0. So let me pull up my calculator here. There we go. All right, so what you're going to do is you're going to press math, go over to number, and you see abs as the first choice, so that's absolute value. So if you hit enter, you're going to see the absolute value bars. So for the first one, I believe it was x minus 3. So if we had to substitute 0 in there, we could type 0 minus 3. Now my calculator, see how it has a blinking arrow? I'm going to have to hit the right arrow to get out of the absolute value. Some of your calculators will actually say the word abs with parentheses. If your calculator looks like that, you're going to have to close the parentheses. Okay, but now I can hit enter and it'll tell me that the absolute value is 3. So you are able to test 0 by using your calculator. All right, let's look at number 3 and 4. Oh, apparently it says 1 and 2 again, but these are the next two problems. Okay, so we see the inequality symbol. So first thing to do is make it into an equal sign. Now, this has changed into an absolute value problem. So your first question is the absolute value alone? It is not alone because there's this -1 on the right side of the absolute value. So we have to get rid of that -1. So we're going to add 1 to both sides. So we are still left with absolute value of 2x minus 7 equals 1. Now the absolute value is alone, so we're going to make two equations. So underline what's inside and break it into two equations. So we have 2x minus 7 equals 1, 2x minus 7 equals -1. Now we need to solve these equations. So I'm going to add, I'm going to add 7 to both sides. So 2x equals 8, divide by 2, x equals 4. And on this side, add 7 to both sides. 2x equals 6, so x equals 3. So there are your two critical numbers. So they go on the number line. Now, we need to test 0. So that means it goes back into the original problem. So we have 2 times 0 minus 7. That is all in the absolute value, minus 1. And we have to figure out if that's bigger than 0. Now, I showed you how to use the calculator. So if you want to get the absolute value in your calculator, and then type 2, parentheses 0, close parentheses, minus 7, close the absolute value, minus 1, you'll be able to figure out what that side equals just from the calculator. If not, you're going to have to do it by hand. So 2 times 0 is 0. 0 minus 7 is -7. Absolute value of -7 is 7. 7 minus 1 is 6. So is that bigger than 0? That is true. That means we shade toward 0. So think about where 0 is on our number line right now. It's over here because 0 is less than 3. So we're going to have open circles and we need to shade toward 0. But remember, you're either shading out or in. Because 0 is out, we're shading out. So even though the arrow is technically going away from 0 with the 4, we only have two options. We either have to shade in or out. And since 0 is outside of these two numbers, we shade out, okay? And then this is an or problem because we shade it out. So we have x is less than 3 or x is greater than 4. Okay, please try this last problem and see how you do. And then Mrs. Penny is going to pass out a practice worksheet, and she will decide whether or not you may work with partners based on your behavior. So please be respectful and work hard, and I will see you soon.